Hi guys, myself Pranav is here to deliver today's presentation on Power Transformer Part 29. As of continuation, the topic is mainly comprised of bushing technology for power transformers for power transformers. As the topic is of continuation, so for your convenience, the link of the previous one is given under the description box. Let's start with resin impregnated synthetic bushings, RIS bushings. RIS bushing technology is an improvised version of resin impregnated paper bushing technology. Resin impregnated paper technology that includes materials such as crepe paper, vacuum impregnated with epoxy resin, where crepe paper is thus to be used as spacer between the capacitive layers. While paper is of cellulose material, which is hygroscopic in nature, so moisture ingress during storage would have become a real threat. The possibility of moisture ingress can have a negative impact in terms of power dissipation and aging of the bushings. Resin impregnated synthetic bushings, that technology is an innovative development for oil-free as well as paper-free bushings, where its solid core section is wound with resin impregnated synthetic fabrics. However, epoxy resin is used as the main insulation material in both the case of resin impregnated paper as well as resin impregnated synthetic technology. But in RIS technology, the open mesh fabric of synthetic polymer fiber that would have been impregnated by alumina on silica powder mixed epoxy resin, whose viscosity is of much higher than that of the traditionally pure resin impregnated liquid. Alumina or silica powder mixed epoxy resins are characterized by their extremely stable dielectric properties, and the condenser core as formed by applying these resins can be molded directly into its final shape, which would have been hardened in a much shorter time. This will be the advantage of using silica powder or alumina mixed epoxy resins. Since the polymer fibers absorb virtually no humidity, so prior to impregnation, coat drying process is therefore no longer necessary, even for the exposed active surfaces, as for example, the oil end of transformer bushings. That is, it's time saving. Its manufacturing purpose is time saving. Area of the upper section of condenser core body can also be directly molded by silicone elastomers for making formation of an insulator at its external surface. In case of RIP, that is resin impregnated paper technology, if the vacuum drying time would have been shortened and the moisture would not be completely dried up during the heating and drying process, then crack might have been resulted by uneven release of thermal stress during solidification process. This will be the disadvantage for using RIP technology. It has been exhibited that higher the electric field gradients and higher the working temperatures, both are the main contributor to accelerate the aging process of paper insulation while using oil impregnated or oil impregnated paper and resin impregnated paper bushings. RIS bushing technology, as it is not sensitive to humidity and have a stable dielectric properties even in harsh service environments, so it would be able to withstand these sort of higher stress levels. High temperature vulcanizing, that is HTV silicon rubber, as is used for weather shades, that is rain shades, of resin impregnated synthetic bushings, which offers superior heat and cold resistance, excellent electrical properties, and commendable chemical stability. Utilization of HTV silicon rubber technology for outdoor insulation has the ability to dampen sound as well as vibration level to a greater extent. And as the hydrophobicity is one of its basic properties that imports self-cleaning even in highly polluted environments. The technology is designed in accordance with IEC 60137 standards and the performance of the RIS bushings that has to fulfill the temperature class E, that is 120 degrees centigrade. Because of no paper, no oil, and no porcelain, so RIS technology is less fragile than porcelain bushing and lighter in weight. You see, in case of RIP bushing, the temperature class is of B type, that is less than 120 degrees centigrade. Now, resin impregnated fiberglass bushing is also comprised of dry type, that is oil-free, paper-free technology, as that of the category resin impregnated synthetic bushing, but has some distinctive difference in condenser core manufacturing process as well as certain advantages over the RIS bushings. Let's see the difference between RIS bushings and RIF bushings, that is resin impregnated fiberglass type of bushings or fiberglass of technology. For RIS bushings, technology is relatively new and has been introduced for commercial purpose in the year 2014. But RIF bushings technology has been introduced for commercial purposes in the year 2003. Technology provides better safety and reliability under all types of operating and environmental conditions. Technology provides better safety and reliability under all types of operating and environmental conditions. Number 3, condenser core is made of wrapping with open mesh fabric synthetic polymer fiber, which is then to be encapsulated under vacuum, where it is impregnated with alumina or silica powder mixed epoxy resin and cured. But for RIF bushings, condenser core is made from wrapping of fiberglass thread that have been impregnated in an epoxy resin bath. Wrapped condenser core is then heat cured, and after which it is machined into its final shape. Only the difference, it is used in only in epoxy resin bath, but here in case of RIS bushing, it is alumina or silica powder mixed epoxy resin and cured. Number 4, for RIS bushings, condenser core insulation is composed of synthetic polymer fiber impregnated with alumina or silica powder mixed epoxy resin wrapped between capacitive screens. Condenser core insulation is composed of fiberglass impregnated with epoxy resin wrapped between capacitive screens. As of CIGRE or CIGRE report formed, which is framed on transformer bushing reliability by its working group A2 in the year 2019, the thermal insulation strength of the resin impregnated synthetic polymer fiber is listed as class E insulation. That is temperature limit rating of 120 degrees centigrade. But for RIF bushings, as per IEC standards, thermal insulation strength of the resin impregnated fiberglass is of class B type insulation. That is temperature limit rating of 130 degrees centigrade. Technology is also available to provide high thermal grade of class F type insulation 155 degrees centigrade. Number 6, outer silicon shades are directly molded on the condenser core, ensuring no gap or opening in the overall bushing structure. However, technology is also available wherever bushing is provided with an insulating envelope where the intervening space can be filled with an insulating fluid or through other medium. But in case of RIF bushings, external airside insulation is of silicon rubber shades that are adhered directly to the condenser core, while ensure no gap or opening in the overall bushing structure and eliminates the need for other insulating fluid or material. Number 7, for RIS bushings, bushings are considered to be maintenance free and offline testing is also to be eliminated by incorporating built-in smart measuring circuitry, which is rather to be sealed within the primary core for continuous monitoring of any variation in capacitance current as generated due to failing of capacitive screens within the condenser core. Same as RIS bushing, in both the cases, if online monitoring unit has shown some changes in capacitance current, no need to take any sort of hasty decision regarding testing or checking of bushings, as because rate of fault propagation inside the bushing is indeed to be very slow. Number 8, deterioration of water ingress and measurement of internal stress are not to be needed. Type test and routine test must be carried out in accordance with IEC 60137. Deterioration of water ingress and measurement of thermal stress are not to be needed. Type test and routine test must be carried out as per IEC 60137. Number 9. Paper and oil-free dry type bushing having with distinctive robustness and being proven performance made severe operating conditions, so no special arrangement is thus to be needed for long-term storage. Paper and oil-free dry type bushing, which requires a very limited sealing procedures, so there is no special arrangement needed for long-term storage. Now, routine maintenance of transformer bushings. Maintenance schedule and intervals would have to be framed through inspection followed by proper diagnostics depending on the physical condition of the bushings. Inspections are thus to be categorized as one, that is routine inspection, scheduled inspection, that is every 2 years or 5 years interval as per OEM, that is to be maintained. Diagnostic type of inspection, that is to assess the excessive partial heating. Number 4, inspection as of local damages. Number 5, inspection for oil leakage or leaky gaskets and other openings. Number 6, inspection for the secured storage of bushings. For all types of bushings, respective routine test and type test should have to be carried out in accordance with IEC 60137. 1. Routine inspection. A. Overheating fault of the bushing. In long-term operation, most of the period, bushing has to carry the full voltage, full current, and has to entertain strong mechanical stress all through. Long-term thermal expansion and contraction. Long-term thermal expansion and contraction would have to instigate the electrical contact wear of the outdoor part of the bushing, and that to be of much concern to overheating failure. The local overheating has caused to accelerate the fretting corrosion process and wear mechanisms, and for which there will be a sharp deterioration of insulation and mechanical performance of the oil impregnated paper or resin impregnated paper bushings condenser core. For fretting corrosion to occur, it is necessary that the contact between the surfaces of two components which are being subjected to a certain electrical load with having a constant cyclic displacement of small amplitude. With the continuous effect of cyclic stress, small gaps might have been appeared between the contact surfaces. Contact corrosion would thus be a side effect of fretting corrosion. Contact corrosion would thus be a side effect of fretting corrosion. While bushings are in operation at maximum rated current, then thermography would have been the best option to check only occurrence of overheating on bushing components. If the terminal contacts together are perfectly clamped, then at the maximum rated current, the bushing outward terminal normally takes a temperature of about 35 degrees centigrade to 45 degrees centigrade above the ambient air. Especially at lower current loading, if there may have significantly higher temperatures as exhibited during a process of thermal imaging through infrared thermography, then it can be concluded a sign of bad connections. Possible reasons might have been loose or oxidized connections. Salient points. 1. As the contact surfaces of the bushing are electroplated, so no use of energy or any abrasive, no use of emery paper or any abrasive articles to clean. You must have to remember these salient points. As the contact surfaces of the bushing are electroplated, so no use of emery paper or any abrasive articles to clean the contacts. Number 2, it is always be recommended for cleaning the contact surfaces with a lint-free cloth using suitable cleaning agent. Flexible jumpers are to be implemented for allowing the dimensional variations so as to take care of the thermal expansion or contraction of the conductors. Just to expel moisture from the joint area of the contact surfaces, it is better to apply contact grease. Flat to flat seating is very important. Number 6, terminal bolts having with suitable spring and flat washers should be properly tightened so as to maintain adequate contact pressure. As to be recommended, average contact pressure would have been at least 1 kg per ampere. That is 1 kg per ampere current, you know. Now, environmental pollution. Type and rate of pollution of a region must be associated with the source of pollution as well as with environmental factors. A contaminant layer of pollution would have obviously be deposited on the surface of the insulator. Mixing with the moist atmosphere, the layer of pollution which might have been dust or salty product is thus to be dampened, causing to increase the rate of conductivity. Once the moist pollutants are dried up, then their adherence would have become much more sticky, which thus in presence of humid atmosphere has made to instigate increase of conductivity and also leakage current. As of consequence, the partial discharge would have been produced along with audible humming sound or humming noise. Ultimately, this has resulted to have a total discharge across the bushing surface, causing a flashover. Salient points to be noted. It is the most important point to accept that any sort of insulating material, even the external porcelain using as insulator for bushings, is not at all indicative as perfect insulator. Hence, a fractional amount of leakage current always exists along the bushing surface from the high voltage conductor to ground. Flow of leakage current would have become excessive while the bushing is in damaged or heavily contaminated condition. So, the bushing are to be cleaned periodically, or otherwise occurrence of flashover might have been exhibited at any time. Normally, once in every 3 to 5 years, a close physical inspection and cleaning of the bushings would have to be performed. This inspection might have been carried out more often if in atmospheres where salts and dust deposition would invariably appear to be on the bushings. This inspection might have been carried out more often if in atmospheres where salts and dust deposition would invariably appear to be on the bushings. Periodic cleaning of air-end porcelain insulator must be done in order to remove these deposited layers with the settled grains of moisture on these layers. All sorts of periodical cleaning and checking of bushings must have to be carried out while the associated equipments are completely in non-energized with firmly earthed condition. That is, it must be in offline condition. If there is a lot of contamination due to adverse ambient influences, then it is better to clean with a wet lint free cloth, wet lint free cloth, or a stream of water. A high pressure water jet cleaning may also be used to remove salt and other water soluble deposits. To interact high humid environmental condition, it is have a better choice to apply a high quality silicone paste wax as a layer on the porcelain surface of the bushing, which may reduce the risk of flashover. It is of much importance to note that prior to any sort of electrical testing, bushing's insulating surface should be thoroughly cleaned, or otherwise the resultant electrical measurement value would have become erroneous. Based on environmental aspects which corresponds to nature of contaminants, the bushing manufacturers have the responsibility to prescribe the particular name and brand of solvents, lint-free wiping materials, cleaning methods, and precautionary measures for the specific bushing surfaces as supplied. By contrast, in the case of composite insulator with silicone sheds, the cleaning prior to electrical measurement is usually not necessary as because of the hydrophobicity of silicone housing. Silicon is such a material, reason hydrophobicity is much more higher. Silicon has the nature to transfer its own hydrophobicity in the contaminated surface and also has to maintain its water repellent properties even with highly polluted contamination and age. If there is a lot of contamination in the silicon surface due to adverse ambient influences, then it can be cleaned with water. According to the severity of deposition, the silicon surface can be wiped off by soaking a lint-free cotton cloth in the 5% soap water solution for light contaminants and applying alcohol or for medium to strong contaminants as per standard IEC 62073. Again, I repeat, according to the severity of deposition, the silicon surface can be wiped off by soaking lint-free cloth in the 5% soap water solution for light contaminants and applying alcohol for medium to strong contaminants, that is as per the standard IEC TS 62073. However, while applying any cleaning solvent, that must be complied with the guidelines as prescribed by the manufacturers. Mechanical damages and oil leaks. Transformer bushing plays a vital role in insulating and transmitting current to outside, and all through there has to counter various aspects of environmental conditions. Mechanical strength would also differ with the basic formation of the bushing, such as pure porcelain bushing, oil-filled bushings, gas-filled bushings, capacitance graded bushing, that is OIP, RIP, RIS, RIF. From the operational point of view, it has been exhibited that most of the bushing failures are mainly caused by the moisture ingression through leaky gaskets or other openings. Poor sealing of the bushing that might have been due to some quality problem or some manufacturing problem for rubber sheet or unreasonable and defective structural configuration that would have been cropped up during manufacturing process or at the same time of installation. Each of the bushing is provided with a prismatic sight lens and this should be oriented in such a manner that the sight lens faces sideways when the bushing is mounted at an angle. If the external porcelain of the oil-filled bushing would have been somehow damaged, then thorough inspection should have to be carried out for cracks and oil leaks. If the oil level is low and there is an external oil leak, then bolts and gaskets must have to be checked, whether bolts are to be tightened with torque wrench as prescribed, the torque as prescribed, by the OEM, and the gaskets are in their respective positions with proper compression. While checking instructions should be followed as per the OEM maintenance manual, and if the values of torque and compression are found to be perfectly all right, then only option to replace the existing bushing with spare one. It is as because with a small oil leak can cause explosive failure of bushing, which in turn would damage the transformer itself. Oil is maintaining an insulation coordination within the internal material section of the bushing. Once the oil level becomes low, and in consequence there is some ingression of moisture that causes sharp deterioration of internal insulation of the bushing and may have a result in explosive failure. If the oil level is suspiciously low, but still there is no visible external leak, then in that case, there might have been an internal leak around the lower seal into the transformer tank. Best option is to reject and replace immediately with new bushings. Periodical checking of bushing oil level by viewing through the oil side glass must be carried out carefully because the oil level would have to vary slightly with temperature changes. Let's stop here. Further to be continued at later stage. Thank you. Thank you for patient listening the video. Kindly do like, share, and subscribe. Your subscriptions would encourage to post more videos. Also share your comments or feedbacks inside the dedicated comment section. If you have any suggestions or specific topic you want, then let me know in the comment section. Thank you. Thank you for patient hearing.